Hello everyone, this is a tutorial on how to use integration to find the volume of different shapes. So we're going to be looking at a cone, a sphere, and a pyramid. So first, let's go and look at the cone. So this is a diagram of the cone. I'll just tell you what the letters represent. H represents the height of the cone. R represents the radius of the base of the cone. Y represents the distance above the x-axis in which the cross-section is placed. Here, that's the cross-section. And the x value is the radius of the cross-section, which is a circle. The formula you need to know is this. And this AY represents the area of the cross-section. So now we can start by finding the area of the cross-section. We know the area of a circle is pi r squared. But in this case, the radius is actually x. So what we're going to do is we're going to replace the r with the x. However, we have to make sure that x is written in terms of y because we are integrating with respect to y. Now, to make that happen, we can use proportions. We can take the height of the whole cone and put the height of the cross-section above the x-axis up here, and that is equal to x over r because it's the radii of the two circles. Now this is true, therefore we can multiply both sides by r. So this becomes x equals to yr over h. Now inputting this into this, we get pi times r y over h, and now this o squared. Now since this is equal to this, just simplifying, we can simplify it even more like that. Now we can input this back in here. To do this, we are just going to write the expression from just now. So we're going to have this, and then a of y just becomes the expression from just now, and then a dy. So now we can find that this expression is a constant because pi is pi, the radius of the cone is constant, and the height is also constant. Y is not constant because the cross-section can be in any position of the cone. And now since this is a constant, we can just move it outside of the integral for easier calculations. So we move this out of the integral. Now we have this expression. From this expression, we can just easily solve the integral. Now, what are the values for a and b? Well, a is just the very bottom of the cone, the height, so it's 0, all the way up to h. Now we can easily solve this entire integral. We take the antiderivative of y squared, which gives us 1/3 of y cubed. And then we quote this. But remember, we need the upper and lower limits. And then of course at the front is a pi r squared over h squared. Now from this equation, well, this expression, we can find that this becomes 1/3 of h cubed minus the lower bound, which is just, well, 1/3 of 0 cubed. Well, that just becomes 0. So all we're left with is pi r squared over h squared, and then you're multiplying by 1/3 h cubed. Now you can start simplifying, so that becomes 1, and this becomes h. So then you get pi r squared over 3h which further simplifies to 1/3 of pi r squared h, which is the volume for a cone. Amazing!